Okay, and this is section 6.2. What are we doing? We want to factor trinomials. Okay, so factoring trinomials in particular with leading coefficient of 1. Okay. So what the heck is this about? It's basically the reverse of the FOILing process. So there's going to be certain forms you'll see, and it's a little harder than just doing FOILing, right? There's things in math that are easy to do one way and hard to do the other. Okay. So multiplying things together is typically easier than factoring them. And that's what we're seeing in this section. So recall doing your FOILing, which I hope you already know how to do. If not, I'm going to show you. So recall FOILing. We'll just take a pair of binomials. So let's say x plus 2 and then maybe x plus 3. Okay. So to multiply those out, you would go first, outer, inner, last. That's the FOIL. Okay, so you go x times x is x squared, plus x times 3, the outer, is 3x, and then plus the inner, 2 times x is 2x, and then plus the last, 2 times 3 is 6. Okay. Combine the middle two terms, and we get our simplified form, x squared plus 5x plus 6. Now we want to go in the other direction, though, right? So you'll be given something like, let's say, so now, what do we want to do? We want to go in the other direction, so we'll be given something like, we'll say x squared plus 6x plus 8. Okay? And what you're trying to do is to turn this into something that looks like this. So we'll go through the method, and it comes down usually to just trial and error. You just sort of set up the parentheses, and then you say what times what has to be x squared and x times x. And then you kind of look at the signs. It's like, all right, the last term has to be a positive times a positive to give me a positive here, or a negative times a negative to give me a positive. In this case, it'll be plus plus. And then you're going to have to think, well, what times what is 8, but when I add it together, it gives me 6. Okay, so 8 times 1 is 8, but 8 plus 1 is 7, so it wouldn't work. So we're thinking 4 and 2, right? So I just sort of have to go through all these different combinations and check them in my head until I get something that works. And generally, in my mind, I will FOIL it back out as a check. So first, x squared plus outer, which is 2x, plus inner, which is 4x, and then last, which is 8. So that's x squared plus 4 plus 2 is 6x plus 8. And we see we got back what we started with. So this is the appropriate factorization. Okay. Okay. So there's going to be 3 or 4 basic forms that we can sort of memorize in order to produce the appropriate factorization. It'll help us a little bit. So what do we have? Well, there's going to be these forms, okay? So the first form we see is x squared plus bx plus c. So and whenever you see that, you're going to automatically write up the following: x plus and x plus. Okay? And it's just because of the way you FOIL this out that forces this form to be appropriate. Okay? So, I mean, your job is, as soon as you see this form with plus plus, you're going to write up your parentheses and then x plus, and you have to fill in the blanks. Okay. Okay, so what am I talking about? Let's take a look. So problem 1, we have x squared plus 7x plus 6. And so as soon as I see that, I write up my parentheses. Okay. I know this has to be x and this has to be x, because when I FOIL it, x times x gives me this x squared. Okay. Now I need something times, so I don't worry too much about the outer and inner. I just go directly to making sure these things work to give me the last term in my FOIL. Okay. So I need something times something that equals 6. And what are those possible somethings? Well, you can have 6 times 1. You could have 1 times 6, of course. You can have 2 times 3, or 3 times 2. The deal is that we want these things such that the outer and inner terms will add up to be 7. Okay, so you can literally say to yourself, well, if I added these up, what would I get? 6 plus 1 is 7. That's going to be the right answer. Okay, you're not going to use 2 plus 3 because that'll give you 5. So what are these things adding together? These turn out to be your inner and outer parts. Okay, so we can compare and contrast. So you say, all right, let's try the 6 and the 1, and down here, let me put in the 2 and the 3. Okay. So up here, let's go ahead and FOIL it out just as a check. And what will we have? I'll get a different color. We have x squared plus the outer, which is 1x, plus the inner, which is 6x, and then the last 6 times 1 is 6. So you see the factors of 6, are 6 and 1. Those are the terms here. It turns out those are your inner and outer terms. That's why we wanted to check to make sure those added to be 7, okay, this middle term. So if you add them together, you get back to where you started. So contrast that with this other factorization, 2 times 3. That'll give me this last guy 6, but the problem is it will give me 5x in the middle. Okay, so you'll have x squared plus the outer is 3x, so this times this, and then the inner is 2 times x, and then the last is plus 6. Okay. Adding them together, you get x squared plus 5x plus 6. And you see, that's not what we want. We wanted that middle part to be 7x. Sure, the last and the first terms work out such that we get the same answers in both cases. You get x squared and 6. It's this middle term which turns out to be kind of the problem, the troublemaker for this particular factorization. Okay, so that one won't work, and it turns out the appropriate choice was 6 and 1. Okay, it takes practice and being good at factoring numbers, so hopefully you got some of that kind of practice in arithmetic. And okay, so let's look at some more of these problems. Problem 3 from the book now. We have x squared plus 7x plus 10. Okay, so it's in our first form. We're going to set up our parentheses. We have an x here and an x here, and then plus plus. Okay, so I'm thinking of factorizations of 10 such that when I add them together I get 7. And you may already know it and it pops up in your head, and that's great. But just for anybody else, 1 times 10 gives me 10, and then 1 time plus 10 gives me 11, so that won't work. Then there's 2 and 5, so 2 times 5 is 10, but 2 plus 5 is 7, and that one does work. So that gives you your factorization. You want 2 times 5. And then, of course, check it. Literally write it out or check it in your mind. I used to always check it in my mind, but for the sake of you being able to see what I did, I'll go ahead and write it out. X times x is x squared, plus x times 5 is 5x, plus 2 times x is 2x, plus 2 times 5 is 10. And of course my pen just died. Okay. So anyways, it looks like it works. 7x plus 10. Yeah, it does. So that's the appropriate factorization. And that's all you need to do. Right? Let's keep moving here. So problem 3.6 of x squared plus 13x plus 12. Okay, set up your parentheses. It'll be x times x. And then we need two numbers that multiply together to give me 12, but add together to give me 13. So say 4 times 3, but those add to be 7. Okay, 4 times 3 is 12, but 4 plus 3 is 7, so that won't work. 12 and 1. If you add those together, you get the 13, so that'll work. So we go plus 12 plus 1. And then again, check it in your mind or write it out. And it works. Okay? Checking in your mind will also make you better at doing factorizations. So when you take college algebra, they expect you to be pretty quick at doing this. You know, they expect it to be automatic. And doing it over and over in your head, you know, refoiling in your head will give you more practice that you're going to need later on if you're going to keep up. Okay, so that was our first form. Let's look at another form. So this time we have x squared minus bx plus c. So the main difference now is instead of having a plus here and a plus here, you'll have a minus and then a plus. Okay? And the factorization that will follow, the setup, will be x and x, just like before. But because the inner and outer terms have to add to be negative, I'm going to have to use a minus minus. Okay, so a negative times a negative will give me a positive. And then when I add the outer and inner terms, they'll both be negative, so that'll add together to give me a negative. Okay, so let's try to do a couple of these. Here's number 8. We have x squared minus 13x plus 40. So I'll set up my parentheses and then start filling in the blanks. So I know the form forces me to use x and x. And it also forces me to use minus minus. Then I'm asking myself, what times what is 40, but adds together to give me 13. Okay, so 4 and 10 maybe, but if I add 4 plus 10, that's 14. That won't work. How about 8 and 5? I think that's the one. Okay, so 8 plus 5 is 13, and sure enough, that's the one. Okay. So I'll go ahead and FOIL that in my mind. And I have first is x squared, the outer minus 5x, the inner minus 8x, and the last 40. And then if I add them together, I get x squared minus 13x plus 40, and that works then. Okay, so our answer, so to speak, our factored form is actually just this thing right here. This would be our answer. This is just check work. Okay, let's try number 10. So we have x squared minus 8x plus 16. I'm going to set up my parentheses. Okay. So I have x and x. And then I need two numbers that multiply to be 16, but add to be 8. And I sort of let the cat out of the bag. 4 and 4. So 4 times 4 is 16, and then 4 plus 4 is 8. So that's what we're going to use. We want minus minus because of the form, and then we'll have to use 4 and 4. Okay. Let's try number 12. So I have y squared minus 8y plus 7. Okay. So again, set up my parentheses. I'll have to have y, and then minus minus. I need two numbers that multiply together to be 7, but add to be 8. There's only two numbers that will multiply to be 7. It's 7 and 1 because 7 is prime. Okay, so 7 plus 1 is 8. So I need to put 7 and 1 in these positions here, and then I'm good to go. Okay, so that was our second form. Now the third and fourth forms, we're sort of going to combine those into one group. Okay. So factoring these two forms, we'll have x squared sorry, plus bx minus c, and then x squared minus bx minus c. Okay, and we sort of group them together because the signs are the same in these cases. You'll set up your parentheses. You'll always use x and x. And then in either case, it's going to be plus or minus. Okay. If you want to know how, which to choose, is it plus or minus, it's based off of which numbers are bigger. So if you have a plus here, you want to put the bigger one in this position and the smaller one in this position. Okay. So B for big, S for small. And the other scenario, you want to put the big in this position and the small in that position. And it's basically just because when you add the inner and outer, you want the bigger number to have the same sign as the second term. Okay. Okay, so let's dive in here and look at a couple of these. There's 14, x squared plus 3x minus 28. Okay. And when I go to my sort of this times this is 28, but add to be, you're really thinking subtraction in this particular circumstance. Okay, so it's no longer seeing if these add the factors add to be 3, but it's rather do they subtract to give you 3. Okay, anyways, let's go ahead and set up our what we know has to be true. Okay, because of the form, it has to be x and x and then plus minus. And then we'll go about trying to find the factorization. So 28, one possible is 2 and 14. We want to look at subtracting them though and see what we get. That's 12. Okay, we want them to subtract to give us 3. So what else? 7 and 4, and that's going to be it, right? So 7 minus 4 is 3. They have to be 7 and 4. So if you don't remember, the bigger has to be positive. So this has to be 7 and this has to be 4. The only way around that is to literally just try each in your mind. Okay. So let's say I accidentally put x minus 7 and then x plus 4. Okay. So in my mind, I would factor it and I would say, okay, this is x squared. The outer is plus 4x. The inner is minus 7x. And then the last is minus 28. That would give me x squared minus 3x minus 28. Right? And that's not good, right? We want the plus. So in this circumstance, you can literally just flip-flop the signs and you'll have the right answer. But let's make sure. Okay, so this times this is x squared, and then the outer, and then the inner, and then finally the last. Okay. Combine your like terms. And we have the appropriate factorization now. So this would be our factorization, and we can go on with our lives. Okay, so that's 14. Let's try some more. So we have a whole bunch of examples here. There's 16. Y squared plus 5y minus 24. I'll go ahead and factor. I'm going to need y and y, and then because of the signs, it has to be plus minus. And I want two numbers that multiply to be 24, but subtract to be 5. So 8 and 3. And of course, those will subtract to be 5. Okay. Check it in your head just to make sure you got the right sort of version. So I have y squared, outer minus 3y, inner plus 8y, minus 24. Combine like terms, y squared plus 5y minus 24. And oh, we got it. Yay. Okay. Let's keep going. So problem 18. We have x squared minus 4x minus 5. Okay. So the form tells me it's x and then plus minus. This time, if you remember, we want the bigger number to be negative. So when we add the inner and outer, we end up with a negative middle term. Okay. So anyways, 5 and 1 will multiply to give me 5. And then when I subtract it, I'll get 4. Okay, so I'll have 5 and 1. But in this case, it's going to have to be 1 and 5. Okay, so the bigger number goes with the negative because when you add them together, you need a negative on the 4. So let's make sure. And if I got it wrong, all I have to do is flip-flop the signs, and it's no big deal. Okay. All right, so x squared first, outer, minus 5x, inner, plus x, and then last, minus 5. Get x squared minus 4x, minus 5, and then that's it. Okay. There's some tricky ones in the book and the homework. So 22 is like that. And we have x squared plus 4x plus 5. Okay. So you could try the factor, and it's a curveball really. From above, our form is plus plus. And then the only possible factorization here is 1 and 5. But it doesn't work. Okay, so if you FOIL it, you get x squared plus 5x plus x plus 5, which would be x squared plus 6x plus 5. Okay. It didn't work, right? Well, there's no way to get a 4 here if we have this particular kind of problem. So what the book is going to want you to write is prime. It's like trying to factor a prime number. You know, there's no way to really factor 7 except 7 and 1. So they'll call it prime, and there's no factorization. Okay. So that was a bit of curveball. It's not like, I know it's not of the form plus minus, but I just want you to be aware they're going to sort of mix them together, and sometimes they're going to try to trick you. Just be aware to be careful every once in a while. Anyways, let's look at another one that's the sort of just a random problem. 10 minus 10y plus 21. So this time the form is, because of this sign, it'll be minus, because of this sign and this sign, it's minus minus. So we have y minus and y minus. And then we want two numbers that multiply to give 21, but add to give 10. So that's 7 and 3. Okay. And then you want to check, just if nothing else for the practice, because you're going to have to do this quickly later on. So y squared, outer minus 3y, inner minus 7y, and then last plus 21. Yep, and it worked. Okay. Okay. The next section, we're introducing extra variables, and it's kind of easy. You just sort of stash one in. For example, let's see, back here, if we had x squared, sorry, you can't see that one, with number 18, what they're going to do is kind of slide in another variable, like maybe 5y squared right here, and then this will be 4xy. And the way you factor is just by plopping in an extra y over here. Okay. So the deal is, if you know how to factor these kind of problems, you'll know how to factor the ones with extra variables. It's really not that big of a deal. So let's take a look. See if it didn't make sense. Hopefully this will make sense. Section 3 then, 2 variable forms. they're basically just the same as before, but you'll have to kind of include in an additional variable. So for example, number 36, let's just take a look. Okay. You have x squared plus 6xy plus 8y squared. Okay. So if it was just a single variable, you would be looking at something like x squared plus 6x plus 8. Okay. And then you would want to factor this guy, right? So you would have two monomers add to 6 but multiply the 8, so x plus 4 and then x plus 2. Okay. What I claim is it's the exact same deal here, except you're going to slap in a y with the 4 and the 2. Okay, so my claim is all you have to do is write x plus 4y and then x plus 2y, and you'll get this object once you go ahead and FOIL it. So let's FOIL it and see what we get, right? So I have x squared, x times x, plus the outer, x times 2y is 2xy, and then the inner, 4y times x is 4xy, and then the last 4 times 2 is 8, and then times y is y squared, right? And then when you multiply, or when you combine like terms, you get x squared plus 4, 5, 6 xy plus 8y squared. Okay, and sure enough, that worked. So it's kind of like a cheap trick. You just slide a y in each of these positions, and if you know how to do these, you can kind of already do these. Okay? So just a couple more, one or two more. Let's try number 40. X squared minus xy minus 30y squared. Okay. So I'm going to just work business as usual. I'm going to set up my parentheses. It has to be plus minus because of this sign. And then the bigger number will go with the negative because of this sign. So anyways, you have x plus x minus. If you want to at this point, you can kind of already put the y in there. We need a y times y to give us this y squared. And then it's a matter of just filling in these blanks in front of the y. Okay? So you want two numbers that multiply together to give me 30, but then subtract to give me 1. Okay, so you're thinking 3 and 10, that won't work. 5 and 6, that seems like the winner. Okay? So its middle guy is negative. The bigger number goes with the negative. And again, if you screw that up, it's no big deal. You just change the signs. Let's FOIL it out and make sure it works. So I have first, it's x squared, the outer, minus 6xy, the inner, plus 5xy, and then the last, minus 30y squared. Okay. Combine the two inner terms, x squared minus xy now, minus 30y squared, and sure enough, we have a winner. Okay, good stuff. One general rule of doing these factorizations, and they're going to become more and more complicated as we go through the semester, but one general rule for attacking these problems is to begin by factoring out any GCF, any greatest common factor. Okay. So section 4, always factor out the GCF. Okay. Okay, so let's look at 43. And what do we have? 3x squared plus 15x plus 18. All right. So before I go and set up my parentheses, I want to do a scan and make sure that I can't factor anything out of these. But in looking, it seems, well, this is divisible by 3, this is divisible by 3, and that's divisible by 3. So I can factor a 3 out. Okay. So 3 times what is 3x squared? That's x squared. 3 times what is 15x? It's plus 5x. And then 3 times what is 18? That's 6. Okay. And then I can go ahead and factor this using the tools we learned in this section. So now I'll write 3 and then set up my parentheses. So I'll have an x here and an x here. The signs have to be plus plus. And numbers that multiply to be 6, but add to be 5. So 6 and 1 will add to 7. That won't work. 3 and 2 will add to 5, though, so that will work. Right. Okay, one freshman mistake is forgetting to bring this 3 along for the ride. That 3 has to be there. Okay? It needs to be part of your final factorization. Okay, let's see, maybe 1 or 2 more. So here, let's look at 56. And we have 3r cubed minus 9r squared minus 54r. So you'll have different kinds of variables in there. They like to use s's and r's and t's and all kinds of good stuff. So just be aware, but it works the same way as the other problems, just with different variables. In this case, we can factor out both a constant and a variable. Okay, so each constant number is divisible by 3, and then each variable is divisible by r. Okay? So what's left over? We'll have an r squared minus, 3r times what is 9r squared? Well, 3r. And then minus, how many times does 3 go in the 54? Looks like 18. And then we could take this part and factor it even more. So we have 3r times, set up your parentheses. It has to be r and r. And then for this form, it has to be plus minus. And it looks like it's going to be 6 and 3. Okay, so 6 times 3 is 18. When you subtract them, you get 3. We want the bigger one to be 6. Let's look at one that has multiple variables in it. So this is 66. We have x cubed y minus 2x squared y squared minus 3xy cubed. Okay. So let's factor out the common variable parts. So it looks like each is divisible by x, and then also each is divisible by y. Okay. So we'll go ahead and see what's left over. So we have x squared minus 2xy, and then minus 3y squared. Okay, you notice if you redistributed, you get back to where you started. Finally, I'll go ahead and factor. Okay. So I'll have x into x. The signs have to be plus minus, and then we're tacking in a y, and then filling in the blanks. Okay, so they have to multiply the 3, but subtract the b2. The bigger number has to be with the negative. So 3 and 1, if you will. And that's it. Okay, note in all of our forms, the first term is always positive. Okay, so if you go back and look through all of our examples, this leading term is always positive. And in general, that's what you want when you go to do these factorizations. So whenever it's not positive, you want to factor out that leading negative. Okay, so let's just look at one of those, 68. We have negative 16t squared plus 80t plus 96. Okay. So we want the GCF as well, but we want to also get rid of this negative, this pesky negative. So I'm going to factor out a negative, but each one's also divisible by 16. So I'm going to also put a 16 out there. And the end result, all of these signs will be changed, right? So it'll be positive and then minus and then minus. Okay? And then the leftovers, we have t squared. 80 divided by 16, I believe, is 5. And then 96 divided by 16 is 6. And now we can factor this using our forms. Okay? So it has to be t and t. It's negative, negative, so our signs have to be plus, minus. Two numbers that multiply to be 6, but subtract to be 5, 6 and 1. And the bigger one has to be the 6. That's pretty much it.